Hey, Algebra 1. This video here starts our new unit on solving linear inequalities and absolute values. Previously, we solved linear equations, where two expressions were deemed as equal by the equal sign. Basically, one expression has equal value to the other. This week's big question is, what is a linear inequality? Okay, and how does it differ from a linear equation? So two parts here that we need to be careful of and considerate of for this week is what is a linear inequality and how does it differ from a linear equation? Okay, we're going to be able to answer that by the end of this week. Okay, so the first thing we want to take a note of is that solving inequalities is similar to solving equations. The only difference is we use different symbols. So if we're looking at the first symbol here that I have circled, that's a right pointing arrow. That means if I have one number here and another number on this side, and we're comparing the two, that means that the number on the left is greater than the one on the right. Okay, make sure that's T-H-A-N, not E-N. Okay. Similarly, if we have the arrowhead reversed, like in the next one, that's considered less than. The number on the left is less than the number on the right. But if we throw in a little addendum here, the number or the same symbol as the one above there, but we throw in that little line at the end of it, that means greater than as well. But we also throw in one more condition, which means it's greater than or equal to. Okay, and that's an important thing there. It's not and equal to, it is or equal to, because a number can't be both greater than and equal to. It has to be one or the other. All right, and then similarly, as you can probably guess, this one is less than or equal to. Okay, I'm not going to run through the examples just simply because these are just examples of equations that we can solve. Okay, so I'll give you a couple of examples there in a few minutes. Okay, but these are all examples here where we can apply these sorts of inequalities when we go to solve them. Okay. One thing you want to keep in mind is our aim is to have our variable or x or k or n or d, whatever it is, it needs to be on its own on the left side of the inequality sign when we go to graph. That is why this is important here, okay? So something like x is less than 5 or y is greater than or equal to 11, okay? For example, when we go to solve an inequality, just like what we see right here, x plus 2 is greater than 12. We would solve it just like an equation and make sure that the variable is on the left side. So we go to solve it, x plus 2, we subtract 2 from both sides, we end up with x is greater than 10. But this really doesn't help us saying x is greater than 10. What is x? Well, in this case, we can translate this to become all numbers greater than 10. Instead of just saying x, simply because it gives us a little bit more context here. Okay, because like we saw with equations, the variable we end up with is a number, but in this case, if we do it with an inequality, we end up with a solution set. Okay, so greater than 10. Okay, so any number that's greater than 10, that is what we would consider a solution for these types of inequalities. Okay, and just to make sure we're on the right page here, let's make sure we know how to use greater than or less than when we compare two values. So the bigger numbers on the left, the smaller numbers on the right for a greater than sign like we see on this page. So 5 compared to 2, that'd be greater than. 6 compared to 10, well 6 is less than 10. Same thing right here. 4 is greater than 3. Negative 1 and negative 2. Be careful here. Negatives work the opposite way. So negative 1 would technically be greater than negative 2. Same thing with 0. Just because it's not positive or negative doesn't mean that it is bigger than that. So we need to make sure that 0 is greater than negative 2. And then 4, any positive number is greater than a negative number. Always. Okay, it's always about position on our number line. Okay. Couple other important points here, things that are safe to do. What I mean by safe is right here. These things do not affect the direction of the inequality. So it doesn't affect the sign, whether it's less than, greater than, less than or equal to, greater than or equal to. We can go ahead and add or subtract the number from both sides, so that addition or subtraction property of equality. And then we can apply the multiplication or division property of equality as long as we're multiplying or dividing by a positive number. And then when we go to simplify a side, or if we combine like terms, okay, that's an important part of solving inequalities. The things that will change the direction of the inequality, so our less than becomes greater than, would be when we multiply or divide both sides by a negative number. Here's a good example. Let's say we have 2 less than 5, okay? If by some reason we need to change the signs in here, we multiply both sides by -1. So if I do that, so times -1 times -1, then we get to -2 is less than -5. But if I don't change the sign, this is a false statement, because if you think about it in terms of negative numbers, what happens is that we're farther to the left with -5 than we are with -2. So in that case, we would have to switch the sign. So -2 is greater than -5. Okay, so that is why we switch the sign here, okay? And the last thing is swapping left and right hand sides. That's just using the symmetric property. Okay, so we have to switch the sides around so that we have variables on one side compared to the other. That's just our symmetric property. Okay, so essentially nothing changes about the inequality. We just have to make sure we change the sign here. Okay, so looking at a couple of examples. We have solve x plus 3 is less than 7. Remember, we want to treat these as if they're just normal equations. So we're going to subtract 3 from both sides. That gives me x is, let's see, 3's cancel, because that becomes 0 less than 4. Okay, because I added and subtracted, doesn't change the sign, didn't multiply or divide by a negative number. It's just like a normal equation, except we have to throw in the condition that all of my numbers for this inequality have to be less than 4. Same thing if we move on to the next example here. We have 12 is less than x plus 5. I want to get x by itself, so I'm going to subtract 5 from the right side to clear out my 5's, and I also have to do it to the left side as well. So 12 minus 5 is 7. We get 7 is less than x. But remember, the idea is we want to have our variable on the left side here. So we have to switch x and 7, but because we're applying the symmetric property, we have to switch the sign as well. So in this case, our solution is going to be all numbers that are greater than 7. Okay. Remember, we want to think of it not as x is greater than 7, even though that is the solution. We want to think of it as this being all numbers. All numbers that are greater than 7 is the solution for this inequality here. Okay. Looking at another example, 3 times y is less than 15. Okay, so because it's multiplication, I'm going to go ahead and divide by 3. Okay, 3 is a positive number here. That means the sign stays the same. 3 divided by 3 is 1. They cancel. I'm left with y here. 15 divided by 3 is 5. And because I didn't divide by a negative, the sign stays the same. So the solution set is all my numbers represented by y that are less than 5. And we can verify this too if we wanted to. So for instance, if I pick a value of y that's less than 5, let's say 4. 3 times 4 less than 15. Well, 3 times 4 is 12. 12 is definitely less than 15. Same thing if I chose -3. 3 times -3 is less than 15. -3 times 3 is -9. Yeah, any negative number has to be less than 15. Absolutely. This is true. This is true as well. Once again, that's a way that we just verify to make sure that it's true. Okay? All right, so -2y is less than -8. Just like the last problem, we want to go ahead and divide by the coefficient here. So that's -2 and -2. -2's cancel on the left side. I'm left with y here. -8 divided by -2. That is a positive number. Negative divided by negative is a positive. So I get a positive 4 here. But once again, because I made the move of dividing by a negative number, I have to switch my sign. So it goes from less than to greater than. So y is greater than 4 here. So all my numbers greater than 4 will make this inequality true. And once again, we can verify this by picking a value greater than 4. Let's do 5. So -2 times 5 is less than -8. -2 times 5 is -10. And because -10 is farther to the left on our number line compared to -8, this is a true statement. Okay, just to verify that we have to switch our sign. Let's pick a value that doesn't make this true. Let's say we pick y is equal to 3. So let's say we pick -2 times 3 is less than -8. So -2 times 3 is -6. -6 less than -8, that's not true. Okay, so this is not a true inequality. Okay, so when we talk about less than, we're talking about comparing one number farther to the left on the number line than compared to the right. So that's why we need to switch our sign on these inequalities. Okay, solve one more example for you here. 2y plus 7 is less than 12. This is going to be a two-step inequality, but we solve it the same way as a two-step equation. We're going to start by subtracting 7 from the left side, subtract 7 from the right side. Keep that equation balanced, okay? 2y is less than, see, 12 minus 7 is 5. Divide both sides by 2 is my last step. That gives me y is less than 2.5. Okay, so in this case, because we get a decimal here, we are looking at all the numbers that are less than 2.5. We could say y is equal to 2. So 2 times 2 plus 7 less than 12. Let's verify to make sure here. So 2 plus 2 is, or 2 times 2 is 4. 4 plus 7 is 11. 11 is absolutely less than 12. Okay. All right, guys, so that's about it for this crash course on solving inequalities. Remember, it's just like solving an equation. You just have to be mindful of the sign, okay? So your homework is worksheet number 15, which should be posted on your Google Classroom. If it's not there, let me know, but it's there. Make sure you're working and submitting it on a separate sheet of paper through Google Classroom. And then you also will need your Springboard books. You're going to tear out pages 35 through 37 in your Springboard books, and you're going to complete problems number 1 through 11 by the next class. If you're in 3rd period or 4th period, that is Thursday, October 15th. If you're in 1st or 7th period, that's going to be due the following class, which is going to be Monday the 19th. Okay, because we have parent-teacher conferences. Okay, so 1 and 7th period, you have until the 19th to finish that up. All right, make sure you're asking me any questions if you have them, and I'll be more than happy to answer them. Have a good one, guys.